Hi all. He's trying to join. I can see Saransh as well. Let me start my sharing. I've added Rahul as well. Hi Saransh.
Hi, Bhawmik. I'm audible?
Yes, you are. Am I audible as well?
Yes, you are.
Okay. Are you able to see my screen as well?
Yes, I can see.
Okay. Let's wait for 2 minutes. I see Rahul and Rohi joining in. Then we can
Mm-hmm.
make a start. In my screen, you all are able to see only the IPython or the Jupyter Notebook window.
Yes, Bhawmik.
Okay.
So right now you are open a Jupyter window with files.
Yes.
That's only visible.
Okay. Because I was trying to share multiple things at once, which I'm not able to do, but that's fine. I'll see how I can do that. Let me open the notebook. Hi, Rahul. I think Rohi is having some problems again joining in because I've admitted him already, but he's not able to join. Let's wait for 1 more minute. Okay. Haransh, maybe a small point for you. Yesterday we have gone through one important concept or a couple of important concepts related to comprehensions. So maybe you can have a look into the recording videos, which I've already shared,
Mm-hmm.
and the Jupyter notebook. You can have a look. If
Yes,
you have any
yes.
questions, do let me know. Yeah.
Okay.
Okay. Let's give it a start then. Then let's give it a start. So what we are going to do today is error handling, and we are going to do this very, very quickly because there is only a few things that I wanted to show you, for which I've opened a few documentations as well, as you may be seeing on my screen. So what we are essentially going to do in case of error handling is something like this, or what we can do in Python is that, let's say we have a function or any piece of code. Error handling is irrespective of in which component we are using the error handling. This is just an example. It doesn't really enforce you to use error handling within the function only. You can use it just like a standalone kind of a test and trial as well. I'll show you examples. Okay. So, but just for an example, let's assume I have a function. Okay. I have some function f1, and within that function, I'm writing some code. Let's say I am taking input as x, and this, what I'm doing with this x is that, let's say I'm simply multiplying x into 2. Okay, and then I'm going to return the value of x multiplied by 2, or maybe I'm taking the power of x to 5, and then I'm going to return this output. Okay, so that's all I'm doing. Now, what I'm not doing as part of this is that if I try to write this kind of a code, my code will be fine, but in some cases, this execution is not handled in a right way, in the sense that, let me just clear all my drawings and come back here. So I'll just take the same example. Just a moment. Oh, he's trying to join again. Let me admit. So I'll create a function called f1, and I'll take an input which is x. Right? We don't define the data types within the function. So I'll just take def of f1, and what I'm going to do is I'm going to return, let's say, x to the power 3. Okay. What happens if I call f1 and say this, when this is passed, oh sorry, this is going to give me an error. Okay, and it is clear that it is giving me an error which is otherwise known as a type error. So every time you get an error like this, the first thing that you notice over here is that what is the kind of error that you are getting. Okay, because you are a technical person, we all are, then we may be able to understand what this is going on over here. Example given, it gives a text like unsupported operand type for double star or power, str and int. It is even to some extent difficult for us to understand, especially for people who are looking at this error in Python language for the first time. So imagine if this kind of an error is coming into your application and somebody is looking into it, then he or she will not be able to understand what is going on. This is a very simple example when it comes to data science, because many a times you are going to share your analysis in Jupyter notebooks like these, and people will try to run them. Irrespective of whether they have their setup properly or not, they may face encounters, or they may will encounter cases where your code does not work on their machine. It may or may not be an issue with your code. It may be a problem with their setup. Then there can be other generic software engineering cases as well, right? In which case, what is going to happen is you are writing a code which does not handle errors in the right way, in the sense that it does not give meaningful output over here, or it does not take any operations here. Okay, so there are two ways in which we can handle this, and that's exactly what we are going to look when it comes to error handling. Right, so what we are going to do as part of error handling is that I'm simply going to rewrite this function as f2, and I'm going to take an input as x. And what I'm going to say, first of all, I did a mistake in f1. That mistake is not a code mistake, it is an attitude mistake. I did not put the doc string, so I should put a function takes integer as input, returns power to 3 of the input. Okay, now if I say here try, so how I am going to handle these kind of errors is that I'm going to have a code block which is otherwise known as a try catch block or a try block. This try catch block concept comes from, let's say, generic programming languages like C, C++, but here we don't have a try catch block. We have try except and raise block. So how we do that is that we are going to give it a try to uh, return x to the power of 3, right? And that's exactly what we have to do. And what we are going to say that this is trying, except in this case, we got a type error, right? Except what we are going to say is going to be something like this. I'll just show you quickly, then maybe I'm going to write. So what I'm going to do is something like this. So I'm going to say, except if there is some kind of an error, I'm going to do something. Okay, so let me go back to my code. And what I'm going to do here is that except if there is a type error, which means the user is passing a string instead of an integer, I'm going to tell the user, you need to enter an integer. Okay, so this is exactly what I'm going to do with function f2. So if I look at the help, it should be able to print what it is doing, takes int as input, returns power to 3 of the input, right? So let me close this and let me run this now with a value 10. Then it is going to return me 100. You run this with any value, it is going to return me the output. Now what happens when I run this using, you need to enter an integer, it does not give me any error, if you know what I mean. So earlier there was a very big error with the stack trace and line number and so on. This entire output is known as traceback or stack trace. Okay. Now this kind of an error is easy for us to understand because we are from a technical background. But when it comes to people who are not from a technical background, this exception handling is far more intuitive as opposed to what was happening earlier. So this is one way of doing this. Okay. The other way of doing this is that I am simply going to say, I hope you all are able to hear me. Hello.
Yes.
Yeah. Okay. Okay, because I was getting a pop-up that I have some problems with my internet connection. Okay, so this is one way of handling the error. So what we are doing is, let's quickly look at what we are trying to do. There is one thing which was not done over here, which I'm going to do now. So what we are doing is, we have a function which is defined here. It has an indentation which is defined here. Here I have the comments or the doc string. Then I have a try block. Okay, so this is the starting point from where my exception handling is going to come into picture. So this is from where I handle my exceptions. Anything which is inside the try block is the piece of code, okay, is the piece of code where I am going to mark a star sign over here. Okay, why have I marked a star sign over here is because I'm not entirely sure whether this code can be taken advantage of or not. Example given in the previous function, I saw that if an user is going to input X with a value of a string, it is quite possible that this line of code is going to fail. So I'm going to identify such injection cases or such kind of injunctions that this code of mine can fail in XYZ situations, in which I'm going to put all the lines of code inside this try block. Okay, and then what I'm going to do, try to run this code. So this code, this part of the code entirely means that I am going to try to run this piece of code where I think there can be errors. If there is, except, or if there is a type error, if there is an input given by the user which does not match the type of an integer or a numeric type, right? It can be an int, it can be a float. But if that is not the case, if there is a type error, if it is a list, if it is a dictionary, if it is a set, then I cannot do this, right? Maybe in some cases I will be able to do, depends on the data type of the values inside a list. Maybe I won't be able to do, but simply put, I expect an integer as an input. I simply expect a single number as an input. If I don't do that, or if the user doesn't do that, this is the kind of error. So this I am going to call the error which I think is going to come when the user is going to execute this piece of code or this function with a value which was not supposed to be passed into this function, in which case I'm going to do this activity. Okay, in which case I'm going to do this activity. I could have actually left this blank, in which case even if you enter anything which is a string, it's not going to do anything, it's simply going to pass. Okay, that is also a possibility. In which case what I see is that if I come down over here, let me just clear all the drawings and come down. So what I'm essentially doing is I'm simply typing a text over here. If I change this and if I simply hide this, this is not going to execute. Why is this not going to execute? Because I have a semicolon here. Sorry, I have a colon here. So I need to do something over here. If I don't do any operations over here, Python is going to cry. So that's why uh, any line of code which is inside this part, let's say if I'm going to hide this, right, in which case Python is going to say I expected some kind of code, it is going to represent that in this format, expected some indented block inside the try block, which I did not do because I have actually commented it, which is not going to be accepted. So you need to write something inside the try block, as well as you need to write something inside the except block, right? I could have written anything over here and it should be giving me some kind of an output. I could have also done this. Let's say I could have also done as simple as this. So what I'm going to do is that if I run this exercise now, it's not going to print anything. It is just a blank line which is printed, which means the function does not do anything. If you enter an integer, or if you are going to enter, let's say, a floating point number, then it is going to do something, or otherwise it's not going to do anything. Okay, let's try what happens if I enter a list with numbers. Okay, if I enter a list with number, I'm just going to see if my list has all the numbers. Sorry. Now what I'm going to do, I'm going to call F2 with my list. Okay, the answer is still the same. Okay, what I mean by that, it is still the same. Let me just put back the error message over here. Let me execute this piece of code. Let me execute this piece of code once more, just to ensure that I have my list, and then let me enter this function once more. I get the same kind of error. It is expecting a single value. It is as simple as that. It is expecting a single value. It can be an integer, it can be a float. Okay, so maybe I'm going to change this integer or a decimal number, right? That's exactly what it is expecting. You are giving it something else. It's going to go inside the except block, right? And it's going to give you this human readable error. Okay, I'm going to paste you this page, which should be the first page where you should go. If you are going to look at, let's say, I'm going to go to chat and I'm going to paste a message over here. I'm going to give these, let's say, documents over email as well, but I've just pinged it to every one of you. Hope you have got that in the group chat. This is the first place where I would go if I have any questions, any doubt on any Python functions. This is docs.python.org. This is the first place where I go. This is the first place where I go and I search for the functions which are already defined over here, right? You can search for the specific version in which you are. Usually almost always the definitions are really the same unless and until you are changing the major version. Now what do you mean by major version? In our case, the major version of Python is 3. This 0.8, 0.2 are just, let's say, minor version and the patch versions. 0.8 is the minor version, 0.2 is the patch set version. It doesn't really matter whether I'm using 3.7.5 or 3.8.2. If I'm using Python 3, almost always these syntax errors or these exception blocks, the ones that is being done over here by people as examples, these are going to remain the same. If that's going to remain the same, I can also ignore the minor version or the patch sets and I can look into the examples. Okay, so what exactly it is saying is that I'm going to, this is something that we have not tried yet. So maybe you can ignore this line. We have not tried user inputs yet. So we are going to ignore this input line, but we can do this as well when we or we can look into this using an example right now. So it's taking some kind of a number which is an integer. Okay, it is taking a number, and if you have entered a number, it's going to break out of the loop. It's going to break out of the while loop. Okay, this while loop is going to continue running. It is saying true, means it is going to continue running until and unless you enter a number. You enter a number, the loop is broken. If you enter something which is not a number, let's say a list or a string or something else, then it's going to tell you, oops, that was no valid number, try again. Right? So this is what this piece of code is doing. This is the simplest example of exception handling. Now at this point in time, if any one of you have any queries, please let me know.
Hello. Hello.
Normally we break without the exception also, right?
Sorry?
Without using within try. We can use the break statement without the exception block also, right?
Yes, yes. Break statement is a generic statement. You can use it without the try except block as well. Break is as simple as you are matching some kind of a condition, and if that event or that condition occurs, you are going to break out of the while loop. So you are here, this break statement is applicable on this while and not on this try and except. So irrespective of whether you have a try except or anything other than that, this break applies on loop.
Got it.
Okay, then I'll move on and I'll show you one more quick thing that we can do. We are supposed to write something within the function, right? That's what we said. So what I'm going to do is I'm going to create a new function. Let's see how this is going to behave. Okay, I'm going to say this is a very bad function. Okay, you will come to know why this is a very bad function. In this case, I'm going to write pass, and in this case, I'm going to write pass. And if I execute this block, it is actually executing. So what it is doing, when the function is executed, it is unnecessarily creating a memory block where it is storing the value of x is equal to 10,000 and it is not doing anything over here. So the reason why I showed this to you is because if you don't want to print anything in the except block, this is what you can do. Okay, so example given, I want to, let's say, again create another function which is, no, sorry, I shouldn't have done that. I'll create one more here. I'll create one more function f4, and in this f4 everything remains the same other than this. I'll change this line to pass, and then I'm going to say f4 and a value of 10. It's going to execute f4 with a value of 1, 2, 3, which is a list, and it's not going to do anything. So earlier I had to write at least one statement or one execution within the except block. I've just shown you there is a way to override that concept as well using the pass statement. This is also mentioned in the documentation. As you can see, there will be certain cases in which I'm going to use pass statement. Okay, the most common example where I'm going to use pass statement is because let's say I'm writing this piece of code. There are a lot of classes and for loops and try and except blocks and so on and so forth. Now what I want to do, over a period of time this code will be completed. As of now only small part is completed. Okay, if that's the case, then I can simply write these pass statements over here that please don't do anything when these blocks are executed, and execute only those parts where I have actually done some kind of coding. Okay, this is really very useful when you are doing things like these. Okay, we have not looked into file handling right now, so that's why I'm not going to go deep into this example. But this example is where we are trying to import a library called system, the very useful library when we are going to work with, let's say, data analysis. And let's say I am trying to open a file which I don't want to read using pandas. Okay, usually I'm not going to do this when it comes to, let's say, the analysis of the data sets that I'm going to do as part of the project. But there will be situations where I need to open files like these. So we are going to briefly look at it at a later stage. At this point in time, simply you can understand from this code that what it is doing is it is taking some file which is my file.txt and it's trying to open it and read each and every line, and then calling some function to do a stripping operation. Okay, let's not go into the details as to what it is doing and what it is not doing, but the important thing is it is trying out these three statements and saying if there is an OS error, give me the error. If there is a value error, could not convert data to an integer, because this is what we are trying to do. We are trying to do an integer conversion of the stripped values of the line. Okay, if there is a value error, print this, except here you see there is a very important thing which we saw, and this is something that is going to be very critical. Let me just copy this and put it over here, and let me just say this, although we are not going to uh, we will not be able to replicate this error over here, but this is just for our knowledge that I'm actually putting it over here. If I execute this code block, it is still a valid block, and what it is doing is that rather than writing a specific error, example given, how did I come to know that this block of code is going to give me a type error, is because I have actually executed it and I've seen that a type error can occur. What if I don't know? What if I don't exactly know what kind of error can occur? I don't know what kind of an error can occur. Let me write something which is very generic. Okay, so what I'm going to do, let me take this. I got an idea. Let me take this and create a new function which is f5. If I take f5 and let me remove this, okay, from here. Let me remove this from here. And what I'm going to say, unexpected error in my program. Okay, and erase. So now I execute this and I put the value. See, unexpected error in my program and the entire stack trace. Okay, why has this happened is because of these two lines. Example given, if I hide this line, okay, this error is not going to come anymore. The stack trace is not going to come. The stack trace can be customized, or it can be forcefully raised inside a program if you are going to say raise. Why is this useful? You may want to know. Let's say you are creating kind of a backend pipeline which is going to do the data processing. We are going to do a lot of data processing. Let's say we have a backend pipeline running in some environment, in some cloud, where we are doing some kind of a processing, and that processing is happening in the backend. It's kind of a chained operation. So activity 1 has to complete, basis which activity 2 has to be done, basis which 3 has to be done, so on and so forth, right? If that is going to be the case, then our basic assumption or setup should enforce us to say that activity 1, A1 should complete if we want to do A2, and then only it should be proceeding to A3 and so on and so forth, right? Now, in such cases, this raise keyword or raising all the errors is really going to be very useful. The reason being, using this raise error, we can do the monitoring of our application. We can generate logs from our application. We can ask some other script or some other program to monitor this log file, and then they can raise appropriate alarms, and then they can raise appropriate steps. Okay, maybe this is a bit confusing for you right now. For people who may have done this already into operations or into their development life cycle, this becomes easy. But please don't worry, when we are going to create pipelines ourselves, we are going to look into this as well. We may have to do this ourselves because we may need to write some kind of pipelines to do some kind of activities. There are ways to write efficient pipelines when it comes to data analysis, when it comes to machine learning. Majority of the times we will be using out of the box pipelining functions. We won't be creating such kind of functions by hand, but in some case you will have to, because there will be setups, there will be organizations who does not really support usage of all of the open source libraries provided by Python, just because they don't believe, or they simply think that there might be some kind of a data problem or a data leakage issue, or somebody will be able to hack my system if I'm using that library, and so on. In which case you may have to write functions like these yourselves, in which case in some cases it will be very beneficial if you are going to raise the errors. Okay, so raise is that keyword by means of which I'm raising it. That's the first point. Second point is, as of course, I'm printing a statement which I can do inside the except block. Third and most important point, when defining the except block, I may or may not choose to write the type of error, which in this case was a type error, which I identified as a type error. I don't know if there can be any other error as well. There can be value error, there can be X error, there can be Y error. I'll have a long list of errors which are written in the errors and exceptions page in the Python documentation. It's not really possible for me to write an except block for each and every error, right? So I simply do a quick trick. I simply say, let there be any error you say that I am getting some kind of an unexpected error in my program. Please pass integer or decimal number to avoid this. Okay, so I get an error like this. Let me just hide this erase part. Then I'm going to get an error like this, and then maybe looking at the error, the user is going to say, okay, no problem, I'm going to pass an integer, and hence it works, right? So these are some of the ways in which we are going to write the try except blocks in which we are going to raise the exceptions. Now there is one more thing which I wanted to show you here. This is not a very good example actually. This to find example is really very difficult. It's really very difficult. But I think we can create something. Let's try to create something. What was this? F5, right? Let me create another function F6. Okay, I'm taking an input X and I'm going to do the same thing. Okay, but this time I'm going to have a condition. The condition is, if input is 0, raise value error with custom error message. This is not entirely true, by the way. Yeah, so I'll write a double star over here. It's not entirely true. You cannot override the entire error message, or at least I have not seen any functionality yet. But let's try to do this. Okay, let's try to see what happens. So my ideology is that I'm going to try something and then I'm going to do something. Okay, so what I'm going to try here, try if X is less than equal to 0. Okay, then I'm going to say raise value error, and I'm going to print your input is less than or equal to 0. Okay, I don't want in this case any else block. I'm simply going to say return X multiplied by 3, except now I've already handled value error. I can get any other errors. I don't know what kind of errors I'm going to get. I don't know. I don't trust my code. I don't know what kind of inputs users are going to give. I don't know what they're going to do. So except I'm going to write the same statement as I have written earlier, and I'm just going to do a copy paste over here just to save time. And now, as you can see, my function has compiled. What happens when I enter a value which is -1? It is going inside that value. See, it's not, oh, yes. It is not taking that value into consideration, right? If it is not going into this block. So this is one of the places where there can be issues, because if we don't format or if we don't structure the program in the right way, then it might go, okay, I have only 10 minutes left. Okay. So it might not go into this block. It has gone into this block. Okay. So what I'm going to do, let me just go back to this example, and then here I'm going to see why is this happening and why is my code not happening. Okay. I'm just trying to do a comparison. In this code of mine, I want to raise a value error. If x is less than or equal to 0, I pass a value which is less than equal to 0, but still it skipped this portion, it went on to this portion. Why so? Is because if you look at this section carefully, what is happening over here, it is trying something which we don't know. It is raising an error known as name error. Then it is saying except name error, and then this. So if I am specifying the error at both the places, maybe this is going to work. So let's say if I do something like this, what is going to happen here? It is the same thing that has happened earlier as well. What is exactly happening? Are you able to at the point? So my point is, inside except, either if I have written the same error or if I have not written any error, this except blocks is actually going to take over your raise block. So either you put the raise block over here, in which case also you're going to get the same error and the stack trace, right? Or if you would really like to raise the error right here with a different kind of a condition, okay, then you need to do this very specifically. Okay, so what I'm going to do, now I'm going to do this. Did you see what I have done? Now I have just made a simple kind of a modification. I'm not using all except condition or all errors in the except conditions. I'm specifically mentioning a type error. Okay, if there is a type error, you give me this error. If there is a value error which I've already checked within this if block, I want the program to print this value. Where is this value printed? Over here. Your input is less than or equal to 0. What is the advantage of this? You get back to the original function that we have written, the first function we wrote. This error is something like this. I'll just take a copy of this. I'll go down and I'm going to paste it over here so that you can see what error we got earlier and what error we are getting now. Okay, so what error we got earlier is this. We got an error like this: unsupported operand times for so and so, so and so, so and so. This is a very difficult thing for people to understand. You want to print the entire stack trace because there is a reason why you would like to do that, because you can clearly specify from where the function was called and exactly where the error was raised, so that people can also see what mistake they are doing. You are expecting people to be somewhat, let's say, technical, and you want to ensure proper logging of your application as well, in which case you are printing a custom message rather than the technical message. So when I said that I can override using raise, you see I dropped 2 stars over here. Okay, with custom error message does not mean that I can replace everything. I did not do that. I was not able to do that. The message that I have given in this bracket is simply overwriting the default message with my message. Everything else in the body of the error of the stack trace remains the same. Okay, remains the same. I can even print some custom values over here as well. So let me just do one thing. Why to waste time? I'll just take this text box over here only. So it gives me an error over here, and then it gives me an error over here. So there is an error. Please see the stack trace below. You can say something like this and you can run the program. So it's going to give you a very nice output. Now there is an error. This is the stack trace and this is the actual error that you have got. Okay, because this is more readable or understandable in this. This is also documented over here clearly. If you read the text, you'll be able to understand what is happening over here. Okay, now we are not going to go inside user-defined functions or user-defined exceptions. The reason being, user-defined exceptions are usually done as part of object and object oriented programming concepts. Okay, so exceptions, if you want to define your own kind of exceptions with own kind of, let's say, messages, let's say you don't want anything of this sort, you want something else entirely, you want a different kind of an exception handling, you can do that, but you can only do that using object oriented programming. We have not looked into that yet, so that is the reason why I'm going to skip it right now. Okay, that's all. That is most of the things that you need to know about doing exception handling. You can read this document. I'm going to take a print of this document and I'm going to share that with you. Don't worry. When I share the video, I'm going to share that with you. But that's mostly all that we need to know when it comes to exception handling. That this is the way you can handle exceptions if you are going to write functions of your own. And there will be times when you are actually going to write functions of your own, howsoever small they might be or howsoever clean they might be. Okay, in the next class we will be looking into something which is even more cleaner than writing a code like this. We are going to use something known as a lambda function. A lambda function, as I may have told you earlier, is something which Python or any other languages have borrowed from the functional programming world, where we have an unnamed and undefined single liner function which helps us perform the work which is usually done by 10 lines or 15 lines of code, right? So that's exactly what we are going to do using lambda functions. Lambda functions are, you can say, by nature similar to the list comprehensions that we have already seen yesterday, in the sense that if you remember, I told you that list comprehensions are very easy if the original code is also easy. So example given, if the original code is as simple as I have a for loop and I have simply an if statement, it's very easy for me to create a comprehension on top of that. But when the things get complicated, to understand comprehensions is a difficulty for your colleagues. Maybe you are an expert, but the person who's going to look at your code is not. So that's where the problems are going to come. So same thing applies to lambda functions. A person who understands lambda function will be able to do a lot of things. Those who do not understand will be ending up into an unnecessary dependency, in which case they won't be able to understand what they are trying to do, right? So that's all, friends. As of now, that's all I have. Let me just save and close this. We have 2 minutes left. I will stop the sharing. Uh, if there are any questions from your side, maybe you can go ahead. I'll assume there are no more questions then. Any other questions on any other topic, not specific to what we have done, maybe something which we have already done earlier? Any questions you wanted to ask? No, I'll take that as a no then. Okay, fine. Now what I'm going to do, as part of the curriculum, something that I had shared in our group as well, we are going through well and we are almost about to complete our, let's say, Python overview section. There are a few things that we need to cover now, which are lambda functions. Then we have some special functions like map, filter, reduce, and so on. We have 3 libraries to look into. We have quickly looked into pandas already. So we are going to look into other libraries like numeric Python, which is known as NumPy. And we are going to look into matplotlib and cbond, which is kind of a visualization library. Okay, so we are going to look into those quickly. Maybe in the next 3 to 4 classes, that's what we are going to do. We will need 4 to 5 more days. And then what I'm going to do, I'm going to start giving you some exercises. So that's what I'm going to share on email. So I'm going to share those on email, and I would like to request you that you can go through those questions and try to answer them and see if you are able to answer them. If you are not, free to look into solutions into Google, or maybe you can ask me as well. Yeah, I think that's all from me. If no one else has any questions, we'll close the call. Thank you so much.
Thank you.
Okay, thank you.
Okay.
Thanks all.
Thanks, Vamik.
Thanks all.
Thanks for
Thanks.